And go. And formally, it is me, back again to speak to you as myself. This is the identity podcast that you're listening to, and I've really thought about it over the last couple of days. The thought has entered my mind, and it's hard for me to get it out of my mind that I just want to change the podcast title to identity. I just want to call it identity instead of the identity podcast. That makes sense to me. It's going to happen at some point. I'm just being lazy and delaying it. Like I need to, the current logo that I have, I need to give it its due or something is the only thing preventing me from just changing the title to the identity podcast. And also I have to get a new logo art, but I'm going to get a new logo that just has the word identity in some sort of minimalist way. Because why not go minimalist if you're going to go at all? Isn't that true? No, I don't. Okay, so I'm going to talk about superposition. A video circulated through my YouTube feed yesterday. It was of a MIT course lecture, and apparently that's something that they're doing. Like MIT is just putting lectures of their college on YouTube, which is that's a big deal. If college is just starting to put all their lectures on YouTube, like people are paying thousands of dollars to have those lectures. I can't believe that MIT is just putting their lectures online, but there's a whole, I think, from the little that I've seen of it, there's a whole lecture on quantum physics that MIT put online that a professor lectured in 2013. So I'm going to watch all of those so that I can learn what quantum physics is exactly, because I'll begin to talk about it sometimes on this podcast, but I don't have the knowledge to really speak from any sort of position of authority. But some of the topics in it I do want to explain in my own language, and so pretty much what I'm going to do, I watched the first episode, I watched the first lecture from this guy on quantum physics, and the lecture is called, if you want to look it up on YouTube, it's called Introduction to Superposition. And you would introduce quantum physics by talking about superposition because literally the idea of superposition is where quantum physics begins. And I'm about to explain quantum physics in my own ignorant way, like in a not authoritative, like I haven't taken a quantum physics class before, but I'll translate the lecture that he said in my own words as best I can. But I feel the need to say that because oftentimes the way that quantum physics is presented to the populace, to regular people, is that you aren't going to be able to understand it, because pretty much if you ever start reading like a preliminary quantum physics book or take a preliminary quantum physics class, the authorities that know about it are going to begin by explaining to you that it's an incomprehensible world to you, and pretty much not for regular people to try to understand, because it's so contradictory. So like in this lecture, this guy, and I don't mean to criticize him as a professor or whatever, because I'm the ass, right? I'm the ass if I'm criticizing the MIT professor. Obviously, I'm the ignorant ass to say that the way that he spoke about it, that there's anything to be criticized about it. Like I don't have a position to criticize him. But that's the whole point of a podcast, is that now we have the chance to just be the ass. But it's just part of my belief system that the importance of subjective explanation for something, because as much authority as professors have, they're still limited in their delivery of it to the lecture format, and they have to tailor it to a bunch of different people at once. So they have to dumb it down for a larger group of people, So anybody who writes a book on quantum physics, they have to dumb it down to have an audience at all, so to make it palatable at all to people. They have to dumb it down, so they have to present it like, oh, this is entirely contradictory world that you're not going to understand. It has nothing to do with the world that we already live in, and you're not going to understand it. So pretty much any preliminary quantum physics talk starts with them telling you you're too stupid to know what it is. And what I want to do is explain that like it's not really that way. It's just we don't translate it well enough. But you could translate it well enough if you had more data points on translation of the world of quantum mechanics and in quantum physics. And the only way to have more data points on the translation of this field is for more people to explain it from their own opinion. That's just part of what I already believe. And so I'm not gonna, I need to explain it. Like I need to be more personable rather than dictatorial, rather than be a dick. I have to be more personal and explain just my thought processes so I'm going to explain superposition in my own words. And so I'll start by saying that. And okay, so I'll explain why quantum physics is important as a field. Quantum physics is important because it's transcendent in a number of ways. Like if you're interested in what is transcendent, then you should be interested in quantum physics and quantum whatever fields, like quantum computing and quantum mechanics is kind of just like a derivative. It's like it's a very similar thing to saying quantum physics. I don't really technically know the difference. It's just that with quantum physics, like that would be the title of the class you'd take in college, and quantum mechanics is just kind of like generally the field that you're studying. But quantum physics is important because it is like the transcendent, the next field of science that we're getting into, that we're interested in talking about, like scientifically as a world. We're trying to comprehend the quantum fields of study, like whether it be quantum physics or quantum computing. And with regard to quantum computing, like every country in the world is racing for this thing called quantum supremacy, because that would be a transcendent thing to obtain. But to understand, and the race for quantum supremacy is the race to be able to comprehend what's going on in a quantum space, so to speak, but for computing, in a quantum space for computing. But like the race to understand that is, to me, I would translate that as it's your race to understand what goes on in an infinite space as opposed to a finite space. And the reason that quantum physics and quantum computing are a transcendent field of study is because they are an authority over us as humans, as people, or as the whole group, or as humanity. We are subject to quantum physics and quantum computing because it carries on in a language, because it just carries on in a way that is transcendent to us, that we don't understand, we aren't able to comprehend it. And it's like our next step is to try to comprehend these major fields of study, what's going on in them, in order to like know the connection between space and time ultimately, or know more about time is another way that I would explain it. Because ultimately what you're trying to figure out is, how does infinity work? So in quantum, and that's what makes it transcendent, and we are subject to infinity, we're subject to what we can't define. And the major fields that we as humanity have stumbled upon at this point in human history that we are not yet able to define are in quantum physics and quantum computing. But quantum computing is kind of like the race for quantum supremacy is you trying to comprehend an infinite space, because you're trying to figure out what goes on in a space between 0 and 1, or like in a spectrum. And superposition is that any point that you would be able to define in a space between 0 and 1 is a superposition of 0 and 1. And in quantum computing, they specifically call it 0 and 1 as the things that you're superpositioning over each other. And so ultimately, to figure out quantum supremacy, you have to understand how every superposition of 0 and 1 works with each other, and where every superposition of 0 and 1 is the total of those constitutes the total space from 0 to 1, or totally constitutes a spectrum. And so if you think of the visible spectrum, all of the elements that constitute it are visible colors, or are different frequencies at different rates. And so in that sense, like quantum computing is discussing that every superposition is like an element, is the same thing. It would be the same thing as saying every single color in the visible spectrum, and understanding how the colors relate to each other. But in order to obtain the knowledge of quantum supremacy, you have to understand how every one of those works at one time. And rather than being able, because you can't focus on any one of them, technically speaking, you can't focus on any one color, because every one color doesn't have value than any other color. They're all the same. But in the same way, just like generally speaking, from 0 at one end and then 1 at the other end, like the space 0 to 1 is important because it is a space, and I would call that like an infinity. It is an infinity, the space within 1. And so in order to understand infinity, you just have to understand the entire inner workings of the thing. But it's impossible to do that because you're trying to describe something that's infinite. And you're trying to describe something that's infinite. So within quantum computing, they would call any superposition, rather than any superposition is a shade of color in the visible spectrum, and it would be a superposition of wavelength and frequency, because frequency is your ordering left to right, and wavelength is your ordering right to left. So it's like a superposition of wavelength and frequency. Now, I've said like something similar in the past about that humans, like people, just the amount that you're able to speak truthfully is only relative, and therefore is not absolutely true or absolutely false. And I'm saying that humans, in their ability to communicate truth, fall somewhere on a similar spectrum, where they are, each person is a superposition of truth and falseness, where falseness is ordered in one direction, and then the opposite direction, truth, is superimposed over it, ordered in the other direction on a spectrum, because a spectrum communicates the two directions at one time. So I'm saying that people are a superposition in their ability, since they're not absolute, since they're finite. Like your finiteness indicates that you are a superposition of like falseness and truth, but you're not solely infinite and you're not solely finite. You're in between them. So like the idea that's presented by superposition it can extend to lots of different areas, but I would say it's like you should see that idea as like what happens within a spectrum is superposition, because it's a superposition of the two sides. And with the visible spectrum, it's a superposition of like at one extreme end absolute frequency, and then at the other extreme end absolute wavelength, and then every shade of color you can see as being some sort of juxtaposition of frequency and wavelength, like whatever, because frequency is the inverse of wavelength, as shown by that they go in different directions on the visible spectrum. But for quantum computing, all that they do is call the spectrum absolute 0 at one end, and then absolute 1 at the other end. So like and to me that's just like an archetypal spectrum, but they call any superposition within it, which equivalently on the visible spectrum is any shade of color, they call a qubit in quantum computing. They call it a qubit, meaning it's a superposition of 0 and 1. And so what they're trying to understand is, how do you arrange the qubits? Pretty much, generally, that's my translation of it with my limited knowledge of it, is that like, how do you arrange the qubits within an infinite space? Because you don't get to consider any one qubit or any one superposition within the space 0 to 1, because no one of them have any value. So like at the point that you are considering it is like, if you're really able to consider it, you're designating it a point, which you're not allowed to do, because it's inferred by the space that there are no points, and that it is a space between the 2 points 0 and 1, because 0 and 1 ultimately are your points, and you're just trying to describe an infinite space. And that's what like the race for quantum supremacy is to understand, because qubits are like, because you have bytes, right? With computers, you have bytes, which are, I think one byte is a 0 or a 1. That's a single, or is that a bit? A bit. I think maybe it's just a bit is a 0 or a 1. And so with regular computing, like to this point, the computers that we deal with and the websites that they bring up for you, and like programs and stuff that you're using through your computer, they're all spoken through bits. They're all spoken through just series of zeros and ones. But any one byte that might designate like you can, I might have to look some of that up, but like you can, let me look up what a letter is as written in 0 and 1, as written in bytes. Binary for 5. Binary for 5. So in order for the computer to display hexadecimal, come on, I'm just looking for the most basic thing. Decimal number 0. Okay, so in order for the computer to display 2, the binary number, the binary code within the computer to display the 2 for you is 1, 0. And in order to display 6, the binary number is 1, 1, 0. And so that's what we've used computers to do, like the code, in order to, the code that it displays whatever for you that it needs to. But quantum computing is not that. It's not computing with either 0 and 1, 0, 1, 1, 0, you know, because quantum computing takes into account that both of the bytes are superimposed, superpositioned, and the way that you refer to that is that any superposition of 0 and 1 is just both 0 and 1 at the same time. It's a superposition of 0 and 1, and that superposition exists within a spectrum that you would call any one of those superpositions a qubit, and then the two extremes of the spectrum are just 0 and 1, but you're trying to figure out pretty much like what would be coding that you could do infinitely as opposed to finitely, because what we have with binary code, or writing a 7 as 111, is a finite expression of computer coding. But what they're trying to obtain with quantum supremacy is an infinite expression of computer coding, and you obtain that by understanding what exists within the 0 and 1, the binary that a computer communicates in. And so like that's a space that we haven't been able, that we're not readily able to define or communicate. And really it's just like it's an infinite space, and it's the antithesis of language as opposed to language as we know it, because language as we know it is predicated on our explanations of our relationships to the physical world, and definitions are based on physical things and physical actions you perform, or at least metaphysical actions that we have an understanding of, that we have risen to a level of intelligence high enough to, like, we can comprehend what thinking is, even though thinking isn't like an outward action. Like so it kind of goes to show that our language has started to develop to include abstract things like ideas, like understanding what anger or peace is, because it's not as easy to just see that physically in the world. But quantum computing or quantum physics is like the extreme of understanding what's going on in a quantum physical world, is like understanding things as they exist entirely abstractly, and entirely abstractly instead of entirely physically. So it's a graduation from the physical world into the metaphysical world. And really the first the first graduation from the physical world to the metaphysical world, or the world of being able to describe quantum physics, because I'm saying that like the opposite of the quantum physical world is just the physical world, is physics itself, where physical interactions can be seen and explained and measured, like a car, like its velocity, a car's velocity or its angular velocity, or the impact of two things going different velocities is like physics, but those are dealing with physical objects and finite objects, and computers, by communicating things in just zeros and ones, are communicating like finite things that we've defined, like they're displaying finite words and language and whatever on the page for you. But the quantum world is dealing with something that's infinite, but ultimately something that's abstract and metaphysical, and deals with some sort of interactions that don't take place in the physical world. But so like your first graduation from physical to metaphysical is really understanding that superposition does exist. So it makes sense that this lecture that I watched, it starts with superposition, and the introduction to superposition is the introduction to say that there is a metaphysical world, because superposition tells you that one thing exists as two things, that two things exist as imposed over each other, where we're normally supposed to understand things definitionally, where any one thing is only one thing. So it's contradictory to understanding itself when we understand things in definitions, is the quantum physical world, because it starts with you seeing that one thing is two things superpositioned over each other, but it's like that superposition exists in a space or in a spectrum, is the way that I would describe it. But in it, I would see it as that because the quantum physical world, like we really started to understand that exists at the time that Einstein was saying all that shit that he was saying, whatever Einstein was doing his Einstein thing, and like just like getting real scientific, and like here's time, and here's like, oh, this is like planets go around, like space time, whatever. Like Einstein was doing his thing at the beginning of the 1900s, at the beginning of the 20th century, and other physicists at the time were explaining stuff alongside him. But like with the emergence of his theory of relativity, and he had the special theory of relativity and then the unspecial theory. But about that time was the time that like they're really studying photons and the behavior of photons, like he was, in order to theorize and explain all the stuff that he did about relativity. But about that time, him and other physicists were studying waves and particles, and whether or not they're waves. And pretty much during the course of scientific history, the particle wave duality, like we explained it at one time to be a particle, and then science later agreed, and I don't know the exact years, but like then science later agreed that a particle wave is just a wave. This is before they would have ever considered it to be dually a particle and a wave. But then they went back and said like, oh, it's a particle, and then they went back and said it's a wave, so they keep flip-flopping. And then at the beginning of the 20th century, with Max Planck and Albert Einstein, science started to agree that the thing that they're studying is both a particle and a wave. It's a superposition of both of them. It's a superposition of a particle and a wave. And for some reason is both of them. And then in 1927, this guy, Heisenberg, no relation to the fictional character from the 2010s, Heisenberg proved this uncertainty principle, saying when the uncertainty principle, and I pulled it up, says the uncertainty principle that he proved. Oh, no, because then I went and looked at binary. Let me go back a couple pages. Okay, so the uncertainty principle states that the more precisely the position of some particle is determined, the less precisely its momentum can be predicted from initial conditions, and vice versa. And that's sort of explaining, it's not exactly wave-particle duality, it's just saying that when you measure a particle, your ability to measure it, like you can shine light on a particle, and then depending on the wavelength that you created, like depending on the wavelength that you shined the light, like because the light can be different wavelengths, depending on the wavelength of the light is how much the position of the particle will move when you shine the light on it in order to observe it, because shining the light on a particle is observing it. And in order to observe it, if you used a wavelength that had more energy or like a higher frequency, it's going to move the particle further away. And so like if you use one that has less energy, less momentum, if you use one that has less momentum, if you use a wavelength of light that has less momentum, it has a lower frequency, you're easily more able to determine what the momentum is, or like the position of that momentum, because the momentum is lower, the movement, the velocity is lower, so you're able to determine the velocity of the light that you're shining on it more easily. But it has like a longer wavelength though, and so like that makes it so that the radius of like displacement of the position of the particle is greater, like it has a greater distance that it can be in proximity from the place that you shine the light, because the wavelength of the light is longer. So it's kind of like saying that, but if the wavelength of the light is shorter, then more energy is being put into looking at the position of the particle, and then the particle moves further away because it's blasted with more energy and it has a greater amount of momentum. And so the more that you shine, like the more energy, the more momentum that there is, the less easily you're able to determine the position of the particle that you're observing. And then the less momentum there is, the more easily you're able to the less, like it's fucked up, like it's fucked up that whatever, I'm mad, fuck that up. So the less particle that their momentum be, the less momentum, like the lesser amount of frequency, energy, light. So like the lesser the frequency is, the longer the wavelength of the light that you're shining on the particle. And so the longer the wavelength, the harder it is to determine the position of the particle, but easier it is to determine the momentum of the particle. And then vice versa. Like the more easily that you're able to determine the position of the particle is, the more difficulty you'll have in determining its momentum and velocity. And so that's like what the uncertainty principle is. But like in general, the uncertainty principle is just stating that it, like a certain ambiguity, like it's pretty much just talking about superposition, or like an ambiguity that exists between two variables at the same time. Like the two variables would be superimposed over each other, kind of like frequency and wavelength, that like the more that you can determine the wavelength, the less that you're able to determine the frequency, something like that. It's just like a general term for ambiguity between trying to measure two variables, where the more that you measure the position, the less you're able to measure the velocity. But it infers that the position and the velocity are inextricably imposed over each other, like they're inextricably dependent on each other's measurings, evaluations. And so it's like, but okay, so that was proved in 1927. So the uncertainty principle, and that idea is also communicating superposition, but just that, like, superposition is like a main facet of quantum physics and is kind of like the beginning of understanding it. But to me, like at the point that we as humanity understood that the particle or the wave is actually a particle wave and is a superposition of two different states, and is the same, it would be the same thing to say is that you understand it to exist in a spectrum, and I would go so far as to say is like you understand it to be a medium between, you understand the particle wave to be a medium between particles and waves, where like the definition medium infers that it is a channeler of some sort of one thing into another thing, or that there's a high and a low over a medium, two different values around it. And in order for it to be a medium, it's a superposition of the two things. But so at the point that we understand that a particle wave exists that way, it exists as a superposition particle wave rather than just a particle or just a wave, that's like the point that humanity, that's where superposition begins for humanity, because we understand that that's a possible thing for two things to exist at one time, rather than that we understand things definitionally and we're only able to digest that one thing is one thing the way it exists in the physical world. So it's like at the beginning of the 20th century when we scientifically understood this, and it like at the same time that we're understanding this, we're understanding that like time and space, that it's the time-space continuum, and that like time is equal to space or whatever it is. And it's pretty much the same thing as superposition itself. And understanding of wave-particle duality is very similar, or at least as long as you understand it through the medium of this word superposition, as long as you understand it through that, like time space is also a superposition, and it works in the same way. Like, and it works in the same way. You can't measure. It works in a similar way, but like it's our understanding that there is time space, and that time is relative rather than definable to one thing or one person or one group of people's evaluation. And so we begin to understand at the beginning of the 20th century that time space is a superposition and that wave particle is a superposition. We begin to understand that superposition is a thing. And to me, that's like humanity collectively arrived at a place, like that's a big turning point, because we understand that this world exists where language is antithetical to language as we know it. Like this world, this lack of language world exists, is what we understand by coming upon the idea of superposition. And so and I would also describe it as, at the point that we understood superposition as a thing, is the point that we begin to head in a direction that in a direction of understanding the metaphysical as opposed to the physical. But it's kind of like, it's the point at which we understand finite and infinite to exist in the same place, or we are and it's the point that we try to understand things subjectively is more the point I'm making. I'm saying that at the beginning of the 20th century, that when we understand superposition to be a thing, and we graduate from definition as one thing to definition possibly has two things, is that we begin to understand things subjectively rather than before we only just understood them objectively. And it brings into light the idea of the dynamic between subjectivity and objectivity, and between infinite and finite, the more that you understand that dynamic existed at all, because it's this opposite of finiteness that you now bring into your vocabulary and bring into your body of knowledge that humanity did. Like, we understood the opposite. There's this opposite of objectivity, and it's subjectivity, and within subjectivity, or within a space 0 to 1, is like infiniteness, but you can't describe it the same way. It's this different world. And so it's this different world you can't describe it with the same language as the world outside of, external to you. And so pretty much in us realizing that superposition is a thing at the beginning of the 20th century, that's when we realize that that's where we comprehend superposition at all, but literally comprehend the superposition of finite and infinite, and comprehend the superposition of subjectivity and objectivity, that there is superposition to be had. But so as it stands right now, we've been studying the world of quantum physics for the last 100 years, or in other words, building the bridge more strongly towards understanding things metaphysically as opposed to just physically. And so that's the direction that we're headed scientifically. But ultimately, I'm saying that just leads to you understanding things. The more that we as a world value quantum physics and quantum computing as a thing, is the more that we lead ourselves to a world where we explain things metaphysically as opposed to physically, because that's what we brought into our body of knowledge by understanding that superposition exists. And so like the base level of superposition, I'm saying, is you realizing that it exists at all. And it is you realizing that there is an infinite and there is a subjective and there is a, there is that. There is like a time to be considered the same way that we used to just consider space. Like, and what you have when you understand that is that there is this superposition world, and like, but we came upon that. I think I said what I wanted to say with that. It's just, I'm just saying that like we brought that into our vocabulary, and you can't go back, by understanding that superposition is real. And the dynamic between space and time is the same one I'm talking about, where space is finiteness and time is infiniteness, because it is at the point that you understand superposition is the point that you're starting to focus on the subjective side of things to be important, or the metaphysical side of things to be important, or the infinite side of things to be important, or the time side of things to be important, because time is superpositional where space is not superpositional. And time is superpositional because it's a superposition of the past and the future. Like any time that you live in, it's just one giant stream, and any time that you live in, as long as you define it to be a time frame, is like a superposition of what came before and what came after. But space is not like that, because it's not because in order to understand space, you do understand space, and you understand that you walk through it and that you're only in one place at one time, and a car going down the highway is only at one place at one time, and if it hits somebody, then there's a problem, because there's like two definitions can't be in the same place at the same time. Like I can't occupy the exact same space that another human is, besides that every single other human has at least slightly a different shape than I do. Like definition, space is just interaction of separated definitions. But like time is something we're subject to. It is superpositional, but just the fact that we're not able to define time. Like we're like, oh, what is time? Like it's just the biggest mystery. What's time? It's just the nature of it being an authority over us, that we're subject to it. Like we can't, but it's just us being able to describe superpositionality is us starting to describe the way that things exist in time, which is the same as like the way that they exist in an infinite space, or like because infinity is what we're subject to. And so like wave particle duality. So it's like quantum physics, the important part of it is the superposition, or like that's the beginning of it. But that's the beginning of you understanding that two things exist at one time. And so that's why quantum physics and quantum computing are like a transcendent body of knowledge. You're transcendent because you're understanding things that we understand to be an authority over us, if you're going in the direction of understanding them at all. And so in this lecture that I watched, I'll try to summarize it. He was saying that, so the main point of the lecture was just to say that like, oh, the world of quantum physics is too contradictory for you to understand. So he brought up all these examples of like, and pulled the rug out from under you, because he'd be like, oh, he's trying to tell you that there's established rules for it, but there actually aren't established rules, is kind of just the point he was making. So he began by saying that you will have a lot of difficulty understanding the course. And so he's talking about, so he starts by giving these examples of an electron goes into an apparatus, and like that's always the beginning of quantum physics courses. They're going to begin by talking about that an electron goes into an apparatus. And so he was saying that electrons have only ever been observed to be black or white. Apparently they've only ever been observed to be black or white. And so he's talking about electrons go into this apparatus that determines whether or not the electron is black or white, so to speak. And then the apparatus has two apertures or outlets on it, and one of them is for white and one of them is for black. And so all the electrons, which we don't know what color they are before they go in, but this apparatus sort of like determines it, or it decides it. It spits out the white ones in one of the apertures. It spits out the black ones in another aperture. And so like pretty much it's saying that 50% of all of them come out as white, and then 50% of all of them come out as black. And then he introduced another variable, which was hardness or softness of the electrons. And then that he's just like, oh, if all the ones that were decided to be white after going through the first apparatus, when they go through the hardness softness one, like does that it's white have any bearing on whether or not it's hard or soft? And pretty much it doesn't, because the variables are exclusive from each other, those two variables. But he was saying that if you determine that, like if you have electrons that you've determined are white, and then you send them through this hardness softness apparatus, which has an outlet for hardness and an outlet for softness, that they'll come out 50% hard and 50% soft, because the whiteness has no bearing on when it goes into this apparatus. It has no bearing on the determination of hardness or softness of the same electron. But that when you send it after that back through a whiteness blackness apparatus, that even though you determined all those electrons to be white that you sent through the hardness softness one, that they are now 50% black and 50% white if you send them through another black-white apparatus, because the hardness softness designation had some sort of bearing on changing the reality of the electron for no reason at all. So that's why it's hard to describe. Like the reality of the electron changed because it went through this apparatus, even though the variable of hardness softness is independent from the variable black and white. So he just brought up examples of that, of why the world is so confusing. And I guess since as long as I'm trying to summarize the lecture that I saw, because I do want to make this like educational, like my talk about quantum physics, besides that I'm just like translating it in my own language. Like I think it's important to describe what superposition is, like outside of quantum physics. Like that's the angle that I'm taking on it in the way that I'm explaining it. And so I'm saying that it exists also in quantum computing. Besides that, it's just like a shade of color in a spectrum. Pretty much if you want to know an example of a superposition, it's any point that you could consider in a spectrum, because a spectrum has two ends of it and is a relational instance. A spectrum is a relational instance, and it's a relational instance between the 2 points at the two ends. And so like if you have the point 5 and the point 6, the space between 5 and 6 is the relational instance between those 2 points, or it's the spectrum between 5 and 6. And you would call it, I would say ultimately you could call it 0 and 1 rather than 5 and 6, because you're describing things in terms of where they don't have value. So you just you will always call the left end, you always call the two ends of the spectrum to be 0 and 1. It's just in this case, it's a spectrum from 5 to 6, and any consideration between that space is a superposition of 5 and 6, because it's more that 5 and 6 have names rather than that they have values. So like a superposition is any space within a relational instance that you designate, and a relational instance is given by that there are 2 points and a space between it, or a relator, the same way that anything is like a medium is like a relational instance. Like a word is a relational instance because it relates you to somebody else. If somebody else heard one of your words, it's like and it's a medium, and that way it is a relator. So he said that about, so my idea was, as long as I'm summarizing the lecture that I saw, I'm going to tell you where my head is headed with it and what I believe, and then it'll be confirmed or denied later with these further lectures, because I haven't seen enough of them to really understand the course or understand what's going on with quantum physics. My idea or my belief is that when the electrons, because the point of all that was him saying that electrons exist at a transcendent level. The entity that is an electron. It behaves and communicates itself in ways and mediums that are transcendent to us that we can't explain. We can't explain the behavior of an electron, and the reason that we can't is because it exists microscopically, and its existence is pretty much within base unit of measure within a space 0 to 1. Like an electron, it exists microscopically, and so we don't understand its behavior is part of what to summarize what he said. And pretty much my idea is that, like, you'd have to focus on what happens within the apparatus of this electron, because what's important is the apparatus and what happens with it. And like what I understand it to be at this moment is that maybe the electron is sort of like the apparatus. The electron is, or at least that's my thought on it, is that the electron is the apparatus, so to speak, because it has to be an apparatus to be a medium, because you have to understand an apparatus to be a medium, because it's like a medium in which that's translating an input into an output. The apparatus is, because the electrons go in and then it goes out. So like at its base level, you can understand the apparatus to be a medium. And so a medium is a superposition. So the apparatus is superpositional in and of itself, and like the electron going into it, that the electron is superpositional, which is something else that he explained. Like he explained that the electron itself is superpositional, and that's part of why it exists transcendently and why we don't understand it, because the pathways that it would take out of either one of the apertures, either like the black pathway out or the white pathway out, that it doesn't necessarily it doesn't take either one of them entirely, but it exists kind of as a superposition of black and white, but it can still be designated as white or black. It's just that any designation you give it is superpositionally white or superpositionally black, meaning that it exists somewhere on the spectrum, and either closer to the extreme end white or closer to the extreme end black is what would give it the designation of either white or black. But regardless of it, any way that you're trying to describe it going into an apparatus and coming out as white and black is that the electron is always superpositional. And so that's something that's transcendent about it, rather than that you could describe the electron as going in one direction, the other direction, both directions, or neither direction. It doesn't do any one of those. So, but it is where both directions is to say that like two different times. I know that both directions sounds like superposition, but like but it's white and black, like superpositionally, meaning it's a percentage of white and black in whether it's given the designation white or the designation black. So he's saying that the electrons themselves are superpositional. And so where my mind goes with it is to say that it's kind of like the apparatus is. And so this is like more interesting to you if you are interested in quantum physics, obviously. And so you kind of understand what the apparatus, or like maybe, hopefully you understand from the summary that I gave on it. But like I kind of understand that the apparatus is, because the apparatus is a medium, and apparently the electrons are a medium, and that they are superpositional of whatever two things you're describing them as, whether it be black and white, hard or soft, or being a particle and a wave, like a particle, a wave, because it is not entirely a particle, it's not entirely a wave, it's superpositional of both of them, meaning that it's a medium. And so what's important to me about it is the use of the word medium, because the word medium is so important and encompasses so many things. And maybe in the next one I always say, in the next one I'll do this, and then I don't do that. The next podcast I will. But so I think that the apparatus is like the electron, because they're both mediums, so to speak. But more importantly, like, let me explain the idea that I'm talking about. It's kind of like that numbers, and well, actually, let me just tell you what my goal is ultimately in understanding this, why it's important to me. It's important to me because I like whatever the transcendent thing is. I want to know what the transcendent thing is. I want to know, like, the field of study that is going to lead to us like leaving the planet or understanding space-time enough to like transmit ourselves over wide areas of space rather quickly or whatever, like whatever it takes for the transcendent thing to happen. Like that's what I'm interested in. And it's like this field tells you how to break down what an infinite space is, or like what the way that time is related to itself or whatever. Like it's this field, and that's why I'm interested in it. But ultimately I want to be able to understand quantum physics enough to I want to be able to understand quantum physics enough to relate it to mathematics, because it's my belief that you can describe all of the relationships between electrons and all that going on in quantum physics better. You can describe it better by saying that numbers themselves do the same thing. If you're just able to name everything a number, but it's kind of like the naming of everything to be a number is what would lead you to understand numbers to exist as different things than just numbers, or different things than just the way that they're ordered. Because the way that we've come to understand numbers mathematically, whatever, to this point before like that we understood that superposition exists, is just that numbers stand alone. Like 6 is higher than 5 and is lower than 7. But what I want to say is that if you understand numbers to exist as a medium or exist as the superpositional instance, then you can give a numerical translation of the language of quantum physics. And what my goal is to do is to provide a language translation of quantum physics that is more layman's terms, first of all, to explain it. Like, I want to explain quantum physics to people and what's important about it, why it's interesting. And to me it's interesting because it's the same reason that you like Elon Musk. Like, Elon Musk is the guy that's going to get us out of the planet, if there's any one guy to do it. Like, that's what's transcendent about humanity right now, is the shit that he's doing with his company, whatever. He's doing things new. Like, I want things to be different. I want things to be new. But and so that's why I'm interested in quantum physics, but I'm interested in providing a language translation of it so that it is tangible to people, and provide a language translation of it. But it's not like I need to provide an ultimate language translation. It's just that we need more data points as translations of this thing, rather than that we're relying on academia to tell us this one way that it is. Because the whole point of the world of quantum physics is that it's kind of like, it's subjective. It's open to but at least it's open to more interpretation than what we would traditionally think it's open to interpretation to be. But it's kind of it's sort of more interpretive, or at least I would be of the belief that you can explain it in different languages. And what I want to do is provide a language translation that's more digestible, but also one that is communicated through numbers themselves. And so numbers, and the way that I would describe that is by saying that numbers themselves are the mediums, or the apparatuses, or you have to look at numbers as the apparatuses, and you do that by understanding a number void of its relationships to plus and minus. So you understand the number first, rather than that it is +3 or -3. You understand 3 as related to plus, minus, times itself, divided by itself. And in that way, you consider the number as an apparatus and as a superpositional instance, or as a medium between all the operations. And pretty much the way that I see it is that if you understand a number and its existence as related to all these operations, rather than that it is different according to all the operations, and you understand the number as a medium, and that's the important part of it. It's just that at the full extent of you understanding its relationship to every single operation, rather than its separation given by every single operation, then you're kind of understanding just the number itself. But and you're understanding abstractness itself, or whatever. And so that's the goal that I have. And I would say that numerically speaking, at the point, it's you have to understand numbers the way that they exist multiplicatively instead of additively. So like let me look up multiplication etymology. And then I will end. And I'm excited to end. Any increase in size, number, so multiplication, any increase in size, number, or amount, act, or process of increasing in number. Okay, so that's pretty much what you would understand already. Multiplication, synonyms are like multiplication, duplication, multiplicity, diversity. The arithmetical sense of process in which one number is considered as an operator on another. Okay, so that one helps me out. So it says the arithmetical sense of process in which one number is considered as an operator on another. And so like maybe what I'm ultimately trying to say in saying that numbers are distinguished multiplicatively is that they are distinguished as operators rather than that they are subject to operators. Like the multiplicative understanding of a number is its existence as the operator or as the medium rather than that it is subject to operators. You know, it is plus 3 to minus 3 multiplied by 3, you know. And yeah, so that's what I want to do. I want to provide like a numerical equivalent for quantum physics, or like explain it in that language, because what you want to do is explain it in different languages. And ultimately, me, by describing this to you, I am just providing the language translation that is my translation of it in the sense that everybody speaks their own language. And so like I speak my own language, and so when I watch a lecture like that, I do translate it into my own words, and everybody has the translation of that lecture into their own words, anybody that's seen it or any student in the class. But the professor is only able to give a general explanation that will apply to all these possible translations of it given by different people, as everybody understands it differently. And so I guess I would be of the belief that the more translations that you have of it is the more that you actually realize the objective truth of it. Like the more translations, because we just don't have enough translations of it as it stands right now. But part of that is just, and like not to knock professors or whatever, like it's just like the elitism of like withholding the knowledge, or the elitism of saying like, because we are at like 100 or so years into understanding this field, but all the professors will still lecture like explaining that people are too stupid to comprehend it, or like that the field is contradictory, too difficult. Like there's a certain amount of elitism in which the information is transmitted to people, like, and the elitism is that like it's, you enshroud it in all this mysticism. Like you say that it's not easy for us as a society to come to a place where we digest quantum physics. But what I'm saying is that people are intelligent enough to understand it. We just don't have the capabilities of explaining it to people at this point in human history. And the more that we understand our imagination to be limited is the more that we don't understand ourselves to be capable of understanding a world that's transcendent to us. But the more that you understand that you are unlimited, like people, like the more that you understand yourself to be unlimited is the more that you will incorporate more of what is transcendent. And so like for example, if I look up uncertainty principle, and so like the Wikipedia definition, like that should just give you like what the definition is, right? Like in layman's terms, like the Wikipedia uncertainty principle definition. And what it says in the first principle is, in quantum mechanics, the uncertainty principle is any of a variety of mathematical inequalities asserting a fundamental limit to the precision with which the values for certain pairs of physical quantities of a particle, known as complementary variables or canonically conjugate variables such as position x and momentum p, can be predicted from initial conditions or, depending on interpretation, to what extent such conjugate properties maintain their approximate meaning, as the mathematical framework of quantum physics does not support the notion of simultaneously well-defined conjugate properties expressed by a single value. And all of that was one sentence. The uncertainty principle implies that it is, in general, not possible to predict the value of a quantity with arbitrary certainty, even if all initial conditions are specified. So the first paragraph on it was 2 sentences. The first thing I said was one giant sentence and entirely convoluted because it incorporates all these terms that you don't know. And so like the transmittance of the information is done, and that's what I'm saying is kind of done in an elite sort of way, where it has to start off as confusing and only to be understood at an elite level, rather than that it's like we've gotten to the point where we're attempting to explain it in layman's terms to people. So it kind of like in bodies of knowledge that are considered to be highfalutin, like really intelligent, you have to be really intelligent to understand them. They maintain that identity in part by like not letting you in on what's going on. They explain it to you in complicated terms that only the elites understand. Like there isn't a lot, but really the only way that you make it digestible to people ultimately is by there being enough data points of people explaining it to themselves, enough like translations of the language of this study. And I think we get to that point more and more now, and because we have things like podcasts, we have people being able to interpret things in their own words. And I think that that's an important, like the podcast is a really important format and medium that we've reached, and like a medium that we've reached as a result of us progressing to the point that we can finally do that. Like I think it's an important point that we've reached. If it is at the point that we don't have to be filtered, or don't have to watch out for things that we're not supposed to say, or don't have to only be said to be like liars or not have the authority to speak, as long as we understand that like a possible translation of quantum physics is like a subjective one, rather than that you have to have the authority at all to translate it. But that's as long as we've reached that point through podcasting, and we understand that the value of the podcast in that way is that we do get to interpret things and speak from our subjective realities, then we've progressed to a level of higher intelligence, in my opinion. Yep. So that's that. I wish I could have been more relatable instead of just, but it doesn't matter. Like, what am I going to do? Like, I want to please everybody. I want to please everyone. Yeah, thanks for listening. Talk to you sometime down the road.